When you hear the word science, it usually conjures up images of maybe explosions or bright colors. Granted, that's the fun stuff, but all of this fun stuff is virtually meaningless unless what it is you are doing produces meaningful data that you can share with someone else. That's why, unfortunately, most of a scientist's time is spent at his or her computer sifting through that data and making sense out of it in order to present it to others. And that's where graphing comes in. This lab will be a simple exercise that will give you plenty of practice with designing and constructing graphs. Granted, you'll be doing it the old-fashioned way with paper and pencil, and not on computers, as you probably would like. Graphing is a very important tool. It allows us to put all of our data on one page without having to sift through a bunch of pages. It tells us a lot about our experiment and a lot about our data. As you can see in this example graph, there are two axes that you use to plot your data. The x-axis shows the word number of pumpkins, and the y-axis shows the abbreviation for the weight unit of pounds. This graph obviously shows a relationship between two variables, or things being measured, the number of pumpkins and pounds. But how did I know which variable goes on which axis? Well, the answer depends on which one of these variables you have the power to most easily control. In this case, it is much easier for you to control how many pumpkins you have, and then put them on a scale to determine how much they weigh. It would be much more difficult, if not impossible, to state a certain number of pounds and then see how many whole pumpkins it would take to exactly equal that value. So since you can easily control the number of pumpkins you decide to place on the scale, on this graph the pumpkins are called the independent variable. Since the weight in pounds depends on the number of pumpkins that you place on the scale, then the weight on this graph is considered the dependent variable. The independent variable always goes on the x-axis, or the bottom of your graph, and the dependent variable goes on the y-axis, up the side of your graph. You will also notice that the line on this graph splits the difference between all of the data points. Thus, it represents an average of the data points. Such a line allows you to generate a mathematical equation for your data that can help explain your data, and even help you predict how your data applies to situations that were perhaps not directly a part of your particular experiment. In this lab, a simple procedure is used to illustrate the concept of graphing. You will attach a meter stick to the wall with the metric side showing, because after all scientific measurements should be done using the metric system. Using a ball that will bounce, you need to place the ball at a certain height along the meter stick. And then, noting the height from which you start, drop the ball and measure how high up the meter stick it bounces. This doesn't have to be perfect. Just be sure you are consistent in your measurements. For example, you may always want to measure from the top of the ball and not sometimes the top and sometimes the bottom. This is the general procedure for this lab, although it will be modified slightly as you go along. You'll be comparing other things, such as how two different types of balls compare on their bounce, or how single trials, how their graphs compare with the averages of other trials. What you need to ask yourself before you actually start constructing your graph is, what are the variables that I'm measuring, and which one is the dependent variable and which one is the independent variable? In other words, does the height from which you drop the ball depend upon the bounce height, or does the bounce height depend upon the height from which you drop it? Once you can answer these questions, you'll have identified your variables. Be sure to review the lab procedure carefully and note the explanation in the appendix about the construction of a graph and an explanation of the specific parts of a graph.